The star Scarab Jew, a red, very tremendous monster found in the glorious collection of Orion, has long charmed stargazers and cosmologists due to its sheer size and quality. If Betelgeuse were set where our Sun is, it would touch the orbit of Jupiter, declaring its huge size. Despite being situated around 642 light-years from Earth, its massive size makes it one of the brightest stars visible to the naked eye. However, Betelgeuse has shown unusual behavior, such as unexpected dimming and brightening cycles, which many experts believe signal that the star is approaching the end of its life. The famous physicist Brian Cox recently offered a straightforward statement that Betelgeuse is on the edge of a stunning impact expected to occur within the next 14 days. This event, known as a cosmic explosion, will mark the end of Betelgeuse's life but will offer a unique opportunity for researchers to study one of the most astonishing and powerful phenomena in the universe. As a red supergiant, Betelgeuse is categorized as one of the largest and most massive types of stars. Its recent erratic brightness fluctuations have sparked theories that it is preparing for a cosmic explosion. When a star like Betelgeuse reaches the end of its life, its core collapses under its own gravity, leading to a tremendous explosion that releases massive amounts of energy, radiation, and galactic material into space. Betelgeuse's impending explosion is expected to be a Type II supernova, a particular type of stellar explosion that occurs when the core of a massive star collapses. This core collapse triggers the release of neutrinos and radiation, creating a shockwave that destroys the star. The explosion will be so bright that it could be visible from Earth without telescopes, possibly even outshining the moon in the night sky for weeks or months. While such an event wouldn't normally be catastrophic if it happened near Earth, Betelgeuse's distance of around 642 light-years means that, although the explosion will be visible and dramatic, it will pose no danger to life on our planet. Nevertheless, the event promises to reshape our understanding of cosmic explosions and other celestial phenomena. A supernova is one of the most powerful events in the universe, releasing more energy in minutes than the Sun will emit over its entire lifetime. Betelgeuse's explosion won't just be a spectacular display but also a crucial moment for science. Experts are eager to witness this captivating event from its earliest moments using various ground-based and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to gather as much data as possible. When Betelgeuse explodes, it will emit a wide range of radiation, from visible light to gamma rays. One of the most critical aspects of the cosmic explosion will be the surge of neutrinos, elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can reach Earth before the light from the explosion due to their ability to pass through nearly everything unaffected. Observatories like Japan's Super Kamiokande and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, providing an early advantage in tracking Betelgeuse's final moments. The explosion will also provide essential insights into the formation of heavy elements. When stars explode, they create and disperse elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will offer scientists a clearer understanding of this element creation process, which is vital for understanding the formation of planets and the chemistry of the universe. While Betelgeuse's cosmic explosion isn't expected to have a harmful effect on Earth, it will interact with our planet's atmosphere and magnetic field in fascinating ways. The energy burst from the explosion, particularly the release of cosmic rays and charged particles, could result in more intense auroras, extending the regions where the northern and southern lights are visible. Perhaps one of the most exciting aspects of Betelgeuse's explosion is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment. For weeks or even months, Betelgeuse is expected to be the brightest object in the night sky, possibly even visible during the daytime. This spectacle will captivate not only professional scientists but also amateur astronomers and the general public, sparking renewed interest in astronomy and the universe. Scientists have long speculated about Betelgeuse's fate, but Brian Cox's recent statement adds urgency. Observatories worldwide are preparing to monitor every phase of the cosmic explosion, and the data collected will be critical, potentially transforming our understanding of stellar evolution, supernovae, and the distribution of heavy matter in the universe. Betelgeuse's cosmic explosion will allow researchers to refine their models of massive star behavior. Given its relative proximity to Earth, it offers a unique opportunity to measure how energy from such an event travels through space. By observing the light and radiation from the explosion as it interacts with the interstellar medium, gas and dust between stars, astronomers will gain a clearer understanding of the universe's scale. Additionally, The event will provide a unique opportunity to explore dark matter and its potential influence on the structure of the universe. Dark matter, the mysterious substance that makes up about 85% of the universe's mass, neither emits nor absorbs light, making it challenging to detect. However, observing how light and matter behave around Betelgeuse after its explosion could provide indirect insights into the role dark matter plays in the universe's large-scale structure. In summary, Betelgeuse's cosmic explosion will not only be a magnificent celestial event, but also a monumental scientific milestone. Its death will mark the end of a giant star, but also symbolize the ongoing cycle of creation and destruction that governs the universe. From death, new stars, planets, and even life itself can emerge. As we prepare for this historic event, the world will eagerly watch the night sky, awaiting the moment when one of the universe's most powerful forces bursts into view. For both scientists and stargazers alike, Betelgeuse's final journey will be nothing short of extraordinary. As Betelgeuse approaches the final stages of its life, one speculative yet intriguing possibility linked to its impending explosion is its potential to shed light on some of the universe's greatest mysteries: dark matter and dark energy. These elusive forces are believed to account for most of the universe's mass and energy, yet they remain poorly understood. Some scientists theorize that supernovae, like the one expected from Betelgeuse, could hold a key to unlocking some of these cosmic secrets. Supernovae release immense amounts of energy and radiation, and some researchers believe these powerful forces might interact with dark matter in observable ways. One fascinating hypothesis is that dark matter exists as weakly interacting massive particles, WIMPs, which could be detected indirectly through interactions with cosmic radiation from a supernova. If Betelgeuse's explosion creates detectable anomalies in cosmic rays or gravitational waves, it might offer critical evidence supporting or refuting the existence of WIMPs or other dark matter candidates. Furthermore, the explosion's gravitational impact could help astronomers study gravitational lensing, a phenomenon where the gravity of massive objects bends light from distant sources. If light from Betelgeuse's supernova is bent or distorted by unseen dark matter, it could offer a unique way to map the distribution of dark matter near the star's location. Additionally, dark energy, the mysterious force driving the universe's accelerated expansion, might also be better understood through data gathered from the explosion. While this remains speculative, observing how light from the supernova travels through space could provide indirect clues about the nature of dark energy. Betelgeuse's supernova as a scientific milestone. The supernova will also mark a scientific milestone in the study of stellar life cycles. Massive stars like Betelgeuse play a critical role in cosmic evolution, forging heavy elements that become the building blocks of planets, moons, and even life itself. Understanding how these elements form and spread through the universe is essential for comprehending our own origins. The explosion will allow astronomers to study how a star's death contributes to the creation of new celestial bodies. Betelgeuse's supernova will enrich nearby interstellar space with elements such as carbon, oxygen, and iron, key components for forming new stars and planets. Cultural and historical impact. Throughout history, humanity has turned to the stars for guidance, inspiration, and meaning. The dramatic disappearance of one of the brightest stars in the Orion constellation will likely spark philosophical reflections on the fleeting nature of existence. In some cultures, celestial events like supernovae have been interpreted as omens or signs of significant change. Betelgeuse's explosion might evoke a mix of awe, curiosity, and even fear as people from all walks of life witness the death of a distant star. The explosion could also inspire a surge of interest in space exploration and astronomy. Amateur astronomers and skywatchers worldwide are already preparing to observe and document the event, armed with modern technology that allows almost anyone with a camera or telescope to participate in the scientific process. A future of discovery. Ultimately, Betelgeuse's supernova won't just be an extraordinary cosmic display, it will also be a crucial stepping stone for future exploration. The data gathered from the explosion will shape how we study other stars, especially as humanity ventures further into space with missions to other planets and stars. Understanding the life cycles of stars and the properties of supernovae is critical as we expand our presence in the solar system and beyond. Betelgeuse's explosion will provide essential knowledge for future generations of scientists and explorers as they unravel the universe's mysteries. In the grand scheme of cosmic events, the supernova of Betelgeuse will remind humanity that the universe is a dynamic and ever-changing place. It will stand as a symbol of both endings and beginnings, a stark reminder that even in destruction, creation is always at work. From the ashes of a dying star, new worlds and possibilities will emerge, perhaps even new life, continuing the eternal cycle that shapes the cosmos. A new era of cosmic exploration. The supernova of Betelgeuse could mark the beginning of a new era in cosmic exploration. As telescopes and observatories around the world prepare to capture the explosion in unprecedented detail, astronomers are eager to refine models of stellar evolution, element formation, and cosmic expansion. Advanced space telescopes like the James Webb Space Telescope, JWST, and Hubble Space Telescope will focus on capturing every stage of the supernova, from its initial burst of light to the slow fade of its remnants. Ground-based observatories equipped with cutting-edge technology will monitor the event across multiple wavelengths, including radio, infrared, and gamma rays. In addition to optical and infrared studies, neutrino detectors like Super Kamiokande and IceCube will search for the elusive neutrino particles emitted during the explosion. Neutrinos will offer critical early data because they escape the star's collapsing core long before light from the explosion becomes visible. This early detection could provide scientists with a real-time warning system, allowing them to mobilize observatories worldwide in mere moments. Gravitational wave observations. Another exciting possibility is the detection of gravitational waves, ripples in spacetime caused by extreme cosmic events. While supernovae are not as powerful as neutron star collisions, the collapse of Betelgeuse's core could generate detectable gravitational waves. Observatories like LIGO and Virgo are on high alert, ready to pick up any such signals, adding a new dimension to our understanding of the explosion. The aftermath, a stellar legacy. Once the explosion subsides, what remains of Betelgeuse could be equally fascinating. If the star is massive enough, its core might collapse into a neutron star, a dense, spinning remnant emitting beams of radiation detectable as pulsars. If Betelgeuse is even larger than expected, it could form a black hole, a gravitational powerhouse whose presence would be inferred by its interaction with surrounding matter. These remnants will remain objects of scientific study for centuries, providing clues about the ultimate fate of massive stars. The expanding supernova remnant, a glowing cloud of gas and dust, will eventually become a stellar nursery where new stars and planets might form. This process mirrors what likely happened in our own solar system billions of years ago. Public engagement and global fascination. Given Betelgeuse's prominence in the Orion constellation, its explosion will capture public attention like few astronomical events ever have. The star's familiar position in one of the most recognizable constellations ensures that people worldwide will look up and witness this cosmic spectacle. Social media, news outlets, and live streaming platforms will likely be flooded with real-time observations and updates. Amateur astronomers, hobbyists, and even students will have the chance to contribute valuable data through community-based science programs like citizen science projects. Educational institutions, planetariums, and science museums will host events and workshops explaining the science behind the supernova. The cultural and educational impact could inspire a new generation of scientists, engineers, and space enthusiasts eager to explore the universe. Philosophical and cultural reflections. Beyond the scientific implications, Betelgeuse's explosion will resonate deeply with humanity's long-standing fascination with the stars. Throughout history, celestial events like supernovae have inspired myths, legends, and even religious beliefs. The disappearance of one of the brightest stars in the night sky might evoke feelings of awe and wonder, reminding us of the universe's vastness and our place within it.